Absolute carnage. So this is what used to be called the cake stand synth, but I've since renamed it the Tardis console synth because it kind of looks like the centre console of Tardis, and obviously that's a much cooler name. I'm making it up as I go along. I have not done very much on it at the moment. It's a bit difficult to get parts right now. Thonk, one of the suppliers that I want to use, is restricting sales because they have less staff because of COVID, which is fair enough. But it just means I've got some bits that are in states of build and not finished. The top, which is like some of the main oscillators, is Look Mum No Computers, Atari, Punk, console, which is 3 Atari Punk consoles in one. And if you don't know, it's basically 3 5.6 timing chips put together into one noise-making machine. Most synthesizers run off bipolar power supply. I'm actually just running mine off 9-volt adapter, so it's going to run off 9 volts DC. That's fine for most of the stuff I want to build, but it does mean I can't. I think it means I can't make anything that needs op amps, so I won't be able to make like a really good performance filter or a really good mix stage because they're things that need plus and minus voltages. So yeah, it's a bit of a limit, but most of what I'm making is really simple and runs off DC, so I figured I'd just go with it. Part way through, this is kind of cool, but it doesn't look like very much at the moment. It's a board with a regulator that will take the 9 volts that's coming in and knock it down to 5 volts and a bunch of resistors. That's it at the moment, but it's part of what's going to be an arpeggiator. Okay, so this is my build of YMNK's Arduino-based arpeggiator, and you should definitely go and check his videos out. I'll put some links in the description. All of the design, all of the code is his work. Basically, the only thing that I contributed to this project is to try and make it as physically small as possible, which just massively overcomplicated it. But the reason I did that is it's going to go on my Tardis synth, which is physically a very small synth. So yes, this is my design. As well as him being the genius behind this project, it's worth watching his videos because he's a very good presenter, but also he's French, so the way he says random is absolutely adorable. Anyway, I thought I'd show you it. The way it works is we're running an Arduino-based code that takes in a trigger signal from, well, in my case, my tests were using an LFO from my Behringer synth, and it uses that to sort of create a bunch of notes, and the notes will either ascend or descend or will be random, and the notes are controlled by switches. And the way that works is all of these input pins are either high, tied to 5 volts, which in my case, these red wires here, which the reason they're not connected to anything is they're going to be wired into switches on the synth. So when these switches are closed, 5 volts goes to these pins, so this pin reads high and then it turns that note on. If the switch is open, and this is the other end of the switch here, these white cables, it goes to ground via a resistor. And so you've got a really cool digital switching system. It's reading high or low, which is either 5 volts or ground. And from that, it knows whether you want that note turned on or off because of the code that's on the Arduino. Now, if you are going to build this, it's worth heading over to the Look Mum No Computer forum because there's been a bit of discussion about this. One point being that apparently this sort of ladder of resistors, it's not really a ladder, but anyway, these resistors which tie these note inputs to ground, you don't need these pull-down resistors. It's something you can implement in the code, and there's examples on there how to do it. I'm just learning. I didn't know that at the time, and I guess YMNK didn't know that either, but it's cool because, you know, we've got a community of people who are contributing to these things. So yeah, we've got the Arduino which runs the code. That's going to put out a sort of stepped voltage state, but that goes into an ADC breakout board, and what this is doing is putting out an analog voltage that is essentially a control voltage between 0 and 4 volts, and that's what actually goes into the synth via these blue and black wires. That's what goes into the synth to provide it with a control voltage and sort of wobble your oscillator about a bit. This is designed to work on a volt per octave, so it's an accurately tuned arpeggiator. However, I think in order to do that, I need to look again at the code because some of it was beyond me, but I think in order to do that, what you need is a reference voltage to be bang on 5 volts. And okay, so one change that I made from Alex's design is originally this V-in was coming off a 5 volt supply. So I should explain. When I decided to do the synth project, I decided not to build a plus 12 volt, minus 12 volt power supply, because most of the stuff that I want to put on the synth will run off just a single positive DC supply. Now, I think I'm going to regret this because there's a bunch of stuff I want to make that's op-amp based. But anyway, that's a problem for future, Chris, and as we've already established, I don't plan ahead very well. So at the moment, this is running off a 9 volt DC supply. This is a voltage regulator, so what this does is spit out 5 volts, which is what's coming over here, and then all these switches that we mentioned before, these are all coming off the 5 volt supply. Alex's design had the 5 volt supply feeding the V in as well, but I don't know if this is generally true, but at least for these Elegoo knockoff Arduinos, their operating range is 7 to 12 volts, I think. So what I've done is just change it slightly. So this is coming off the 9 volt pin, but all of the comparator type maths is being done off the 5 volts. Yeah, so there's a bunch of parts as well, and they go into analog inputs, and the voltage ranges there are used to determine things like the range that the arpeggiator works over. It's a really nice bit of code. I don't understand all of it, if I'm completely honest, but I do recommend checking it out. And we'll have a clock input, which is what comes off my LFO, and control voltage out. I'm delighted with it because I've managed to make my Behringer sound, well, it started off sounding like a sort of 60s kids schools program theme tune that's very quickly descended into something absolutely cursed, and I'm very happy with that. I will share it. I'd like to incorporate this into the synth somehow. It's basically echolocation like bats use, but for Arduino. I'm thinking I could use it to make CV, like kind of theremin wobbling about, proximity sensor kind of thing. I'll just offer this as a piece of advice for anyone else who's kind of in a similar position to me, where they know a bit, maybe just enough to be dangerous. This is fairly complicated for me. It might not seem it, but it's fairly complicated for me. I would just do simple things like, okay, so every time I put in a new connection to Earth, it's kind of hard to see because it's so small, but this is the Earth rail here. Every time I put in a new connection to Earth, I'm using my meter to check I've got continuity between the place where Earth will connect on the power supply and this new bit that I've just added. So there's a lot of sort of checking continuity with the Earth, checking continuity with the positive rail as well when I put new things in there, checking that the cables that go to the end of these resistors actually read the right resistance, so that I know I've got a path that the electricity is supposed to be following and that it's doing the right thing. The one thing I found really difficult to test was this, because I don't fully understand, I don't understand very well at all how the digital to analog chip works. So this was hard to test. All I could do really was look at the voltages coming into it, the voltages coming out. I did some weird stuff like listen to the output of this, and it's a control voltage, so it's not great to listen to it because it's kind of, bumping the speakers in a not very natural way. But even that was quite useful because at low volumes, when I had the register of this set wrong, I could hear a lot of hum. But when I had it set correctly, I had a clean signal. So I think you can sort of go through piece by piece, check continuity, check voltage values, check for earths, physically check that your soldering looks good, and that, when you solder, you actually see it start to flow into the joints and it's making a proper sort of chemical connection as well as an electrical one. And yeah, I think it's all common sense, but I feel like a lot of stuff, unless someone said it, you don't necessarily think about it. So yeah, give it a go, and I'll try and help if anyone wants help, albeit from a not very much more experienced perspective. So yeah, I might find a solution to the op-amp problem. I need to read this. which I haven't done yet, obviously. Basically, I think I found some op amps that will work. They'll take a comparative voltage off my single DC voltage, which would be really cool because it means I can make things like properly resonant filters and maybe a proper balanced buffered mixer and which would be really handy. So yeah, bit of bedtime reading. So on the video for building this, Sam, Mum No Computer, made an excellent point that if you put the face panel on before you put the tool components in, like the jack sockets and the pots, you can make sure that the holes on the top line up. And it sounds kind of obvious, but I'm not very good at planning ahead, so that's exactly the sort of advice that I need. It's just that moment sometimes when the solder flows that's like super satisfying and relaxing. So my parts that I've been waiting for arrived from Thonk, and it's these pots and these jacks. I've not used these form factors before, but they're really nice. They fit really tightly on the board, so yeah, give them a go. All that's left to do now is to pop in the 3 556 chips, then I can test it. I think the specs are for a red LED, and different coloured LEDs do have slightly different voltage drops, but I don't think it's going to make a huge difference in terms of the performance of the circuit. This is going to sound chunky anyway, I hope. Okay, so after this I need to make more oscillators because frankly I can't have a synth with only essentially one oscillator out, and some filters. I don't know how because they need a bipolar supply, but that's future Chris's problem. So yeah, the cake stand was a prop for the museum short film, which didn't get made actually, but still exists in various forms, and the base is made from a cheese board, which, well, for some reason one Christmas I was given 2 cheese boards, which is amazing because I don't eat cheese.